150 years, the theory is that probably the decline in strength will follow what's called a logarithmic digression instead of a linear digression. Let me show you the difference here, what that means. If you go backwards in time, this would be linear, meaning a straight line. If it goes logarithmic, it may be like this. And without getting into all algebra and geometry and trigonometry behind this, these are called two different progressions. For instance, if you doubled the amount of money in the bank every year, or every day, or every month, or whatever. There's the story told about the guy who's told his friend, he said, I will give you $100,000 a day for 30 days. If you will give me a penny the first day and double it for 30 days. Double it every day for 30 days. If I made you offer 1 or offer 2, which one would you take? Offer 2. You get a lot more money. Now for the first 20-some days, this guy racks up the dough, man. After 20 or 22 or 24 days, somewhere in there, it starts to really eat him up, and all of a sudden he loses it all in a hurry. This would be a logarithmic or a geometric progression. Malthus was all upset because he thought that the population would increase geometrically and the food supply could only increase arithmetically or linear. Now he's wrong, but that's what he thought. And that's what got Darwin all upset, saying, well, if there's more people born than can survive, then only the weakest should die off and the strongest should survive, and that's the way it's supposed to work. That's all led to Darwin's thinking. So the Earth's magnetic field, we've only got a short piece of data to measure. You got a series of points for 150 years. Based on that short section of information, you have to decide, is it going to be a geometric or a linear? Either way, it creates a problem for the evolutionist. It creates more of a problem if it's geometric, but even if it's just a linear digression or progression back into time, it still creates a problem. Thomas G. Barnes at University of Texas, El Paso, taught physics there for years. He said that the Earth's magnetic field is declining at such a rate that it cannot be more than 25,000 years old. He said if you go back in time, actually I've kind of got it backwards here to where normally the way you'd look at a graph, it's declining. The strength is declining. This has been measured, let's call this the year 2000 and this the year 1850. As the magnetic field gets stronger and stronger and stronger, this would indicate a hotter center to the Earth or more movement. If you go back in time, how far back can you go before there's too much heat? And he calculated at 25,000 years ago is the limit where life could not exist on Earth. Now, there is no question in anybody's mind that the Earth's magnetic field is getting weaker. That is never questioned by the atheists or evolutionists or anybody. They all agree it's getting weaker. How do you handle this data is what the problem is. The creationist says, well, this proves the Earth is young. The evolutionist says, no, this is just part of a cycle. It's declining now, but it's reversed through the years. Remember we talked about magnetic reversals? There are no magnetic reversals at the bottom of the ocean floor. But they say, well, the Earth's magnetic field is reversing. This idea of continental drift and Earth's magnetic field reversing, flipping, is all, I think, a very desperate attempt to salvage the billions of years they need for their theory to look reasonable. When the simple fact is, the Earth is not billions of years old. Okay, so the magnetic field is declining, and this indicates less than billions of years, certainly. It indicates it cannot be billions of years old, and this indicates carbon dating cannot work. Now here's why. The Earth's magnetic field, as it declines, it allows more radiation to get in. One of the protective barriers we have around the Earth is our magnetic field. Hang on here. There we go. The magnetic field protects us from radiation, along with several other things your atmosphere have. But if the magnetic field is getting weaker, more radiation gets in. And it's that same radiation that makes carbon-14. So if the magnetic field was stronger in the past, you would have less carbon-14. So any plants that were breathing this carbon-14, if we're going to check them against today's standard, we're automatically going to get a wrong number because they had less. So the magnetic field is one of the factors affecting the amount of carbon-14 in the atmosphere. Textbooks are going to say the Earth's magnetic field has reversed. This is a typical textbook saying there are areas of reversed polarity. Now the reason they teach this to the kids, even though it's not true, probably the author of the textbook does not know that it's not true. He thinks the Earth's magnetic field has reversed. Let me explain what happened. They dragged a machine across the bottom of the ocean, and plus they did drilling to drill down, bring up samples of rock, and see how strong is the magnetic field in this rock. When you get into iron or magnetite or metals, rock that will store a magnetic field, they can check how strong is the magnet. Measure it, or so many Gauss or whatever units they use for measuring the Earth's magnetic field. They find out there are areas of stronger and weaker magnetism. And so what they did, they graphed out as they moved across the bottom of the ocean. They said, oh, here's an area, here's stronger here. Now it's weaker, weaker, oh, stronger, stronger, weaker, weaker. And it made a wave, a sine wave they call it. It goes, curves up and down. It was weaker and stronger and weaker and stronger and weaker and stronger. Some guy drew a line through the middle of the sine wave and said, everything below this line is a reversal. And right there's where the problem is. It wasn't a reversal, it was just weaker. If we lined up everybody in the world and found an average height, we'd have short people, tall people, short people, tall people, short people. We draw a line through the middle, find the average. Is everybody below the line underground, or are they just shorter? They're not underground, are they? They're just shorter than the average, that's all. And everything below the line was just less than the average intensity. It was not a reversal. Now how they get by with this, I don't know. But I think nobody ever checked out the truth is what happened. There are no magnetic reversals on the ocean floor. Only areas of stronger and weaker magnetism. Okay, suppose you can prove there are no magnetic reversals, only weaker areas of magnetism. Now we need to come up with an explanation for why is one area weaker than the others, and we've got that on video number 6. We'll get to that. But what does this do to the evolutionist? You just took away the idea that there are reversals. So now you go back to your original problem. The Earth's magnetic field is getting weaker. So how old is the Earth? If he wants to believe it's billions of years old, now he's going against some clear scientific evidence. It can't be billions of years old. That's for sure. Okay, the Earth is slowing down. Now scoffers really attack this, what I'm about to give you here, this proof of a young Earth. But in 1990, the newspaper article here in Pensacola said, we're going to have to give 1990 one last tick. On New Year's Eve, they added an extra second into the clock. This article says, regular clocks use days as a measure, which are growing longer by 1,000th of a second or more daily as Earth's rotation slows. The Earth is slowing down. This is Astronomy Magazine, 1992. They said Earth's rotation is slowing down. June will be 1 second longer than normal because we're going to have a leap second. It's called the International Earth Rotation Service. One of those government jobs. Somebody needed, somebody's uncle needed a job, so they started a new program to keep track of this. But the Earth is slowing down. Since they started keeping track of this, I believe 1973 is the first leap second. They've been adding a second to the clock about every year or year and a half. This International Earth Rotation Service decides when to do it. They try to do it in January or June. Now, do they wait 12 months or 18 months? That varies. What would slow the Earth down? The Earth is spinning in a vacuum. There's nothing in space. Why would it slow down? There are at least 3 factors that slow it down. Who can tell me what any of them are?
Gravity
Gravity from the sun, well, because of the inverse square law, gravity from the sun is pulling a little bit stronger on the close side of the earth than it is on the far side of the earth. There's an 8,000 mile difference there. So there's a little more pull on the near side than there is on the far side. I don't know if it's even measurable if the gravity from the sun would slow it down. The three factors, maybe a good bonus question at least, maybe not, or if not a quiz question, but one is the earth is spinning but the inside is liquid. So there's going to be a little bit of internal friction by the liquids moving around inside. If you were spinning a basketball that was full of water, there'd be some friction inside with this liquid versus this hard surface. And the crust of the earth is not the same thickness at all places. It's thicker under the continents and very thin under the oceans. So you have a liquid moving a little bit inside of a ball that is not smooth inside, because the crust of the earth is not consistently uniform and smooth inside. The liquid down inside, when it comes out, we call it magma. Volcanoes put out the lava. That's magma, the liquid rock coming out. The place where it changes from solid to liquid, nobody's ever seen this. This is theoretical. But they did try to find it, actually. They were going to drill down and try to find where does it change from solid to liquid. Some scientist, I forget what country he's from, he had a strange name, Moho Ravisic was his name. So in honor of Moho Ravisic, they named this place where it changes from solid to liquid, they named that area the Moho Ravisic Discontinuity. For short, they call it the Moho, okay? M-O-H-O. They spent a lot of money trying to drill down to find the Moho. Where does it change? The way that they know it changes from solid to liquid is pretty surprising and pretty ingenious the way they do this. When an earthquake is happening in San Francisco, it shakes the ground, they can have a machine here in Pensacola that can sense the ground shaking that far away. I mean, if I stomp on the floor here, can you feel it where you are? Well, if I drop a 20,000 pound weight on the floor here, they'll feel it down the block, right? As the earth shakes, you can feel it different parts. Now, the movement travels different through solid than it does through liquid. So they noticed if you have an earthquake in San Francisco, in Tokyo, their machines move. A few seconds later, they move again. It's not a different earthquake, it's the same earthquake, but they traveled through the crust of the earth one speed and through the liquid at a different speed. Yeah, they're called S and P waves, I believe. You can study that in earth science about the different. Plus they can discover, as the earth shakes, if it's shaking in San Francisco, on the opposite side of the world, which would be someplace near Australia, I would guess, they'll notice they don't get the right kind of S and P waves. It's like there's a shadow, and that's how they've determined the center of the earth has different parts. It has the mantle and then the core. They said there's something solid in the core, and I don't know how much is proven, but it is pretty reasonable that there seems to be a shadow to the S and P waves, or whichever is which, as they go through the earth, indicating there's something even more solid inside called the core of the earth.
Could it mean that there's something solid, or that could it possibly be hollow?
Or hollow, yeah.
And it's spinning and it throws it.
Yeah, if it's hollow, brings up another interesting set of theories you could come up with on that. Who knows? But anyway, the earthquakes, with these, they can tell what the crust of the earth is like. So one of the factors that is slowing the earth down is the liquid center. The other factor is the liquid surface. If you ever been standing out in the ocean and a wave hits you, knock you down, right? Well, those waves are hitting the beach all the time, aren't they? As the tide comes up, the water's pushing against the land. That's going to eventually slow it down. If you were spinning a basketball that had water all over the surface, the friction of the water dragging on the surface would slow your ball down faster. So you have internal friction. You also have external friction. This is from the tides. It's actually, there's a name for it. It's called tidal braking. It's like putting the brakes on. The tides have a very minimal effect, but they do have an effect. The tides are slowing the earth. The third factor, surprisingly enough, because the earth is spinning under a hot sun, the sun heats up the air, causes it to expand. As it expands, it rises. As it rises, cold air goes in the bottom. So you get hot air rising, cold air falling, rushing in, and you get wind currents. The Earth has obvious wind currents, okay? The spin of the Earth, combined with the heating and cooling of the Earth, causes what is called the Coriolis effect. Some guy named Coriolis made it up, I guess. But the wind blowing against the mountains has a very slight slowing effect. So the wind patterns tend to slow the Earth a little bit. The tides slow it, and the internal friction. Those are at least three. There may be more factors, but those are three that I know of. The bottom line is the Earth is slowing down, and it's measurable. These are the dates when they've added a leap second to the clock. From 1973 up to 1996 I have here, for when they added a leap second. Because the Earth is slowing down. Now if you go backwards in time, obviously the Earth used to be going faster. I wouldn't put a date on this one and say if you went back, 1.4 billion years, you couldn't live here. Because then as soon as you put some kind of date, some skeptic's going to figure it out and say, no, it's 1.7 billion, see, you're wrong. And he's going to miss the whole point. The point is it can't be billions of years old. So what I say in my young Earth proofs now is, look, the Earth is slowing down. This everybody agrees with. This means it used to be going faster, obviously. We know of no factor that's going to add energy to the Earth. If a meteor hits the Earth that's spinning, there's a possibility it'll speed it up a little bit. But just random chance is going to say an equal number are going to hit it on the wrong side to slow it down. I mean, odds are 50-50, right? So you can't count meteors here as anything to get excited about. So the Earth is slowing down. There's the Coriolis effect is the name of it there. That's what causes the wind patterns. And that's an interesting study which you should get into in earth science about why do we have prevailing winds. Here in Pensacola, it nearly always comes from the northwest. Other parts of the world, the wind almost always comes from a different direction. Depends on how far you are above the equator and all that stuff. So if the Earth were billions of years old, it used to be going faster. And I make a joke out of it at this point and say, well, if you think the dinosaurs lived 200 million years ago, man, I know what happened to them. They'd have been thrown off the Earth. Now the truth of the matter is, at 200 million years ago, it probably wouldn't be real sufficient, or real significant as far as the effect. In 6,000 years, it'll make a few minutes or maybe 15 minutes a day difference. You go back a few billion years, it starts to make a real difference. Now several planets today are spinning awful fast. I believe it's Jupiter spins every 10 hours. That's a giant planet for one thing, and it's spinning every 10 hours. Venus spins once every 443 days, or something like that. It's real slowly spinning. So different planets have different spins, and who cares? You can learn all that stuff if you like. But the Earth is slowing down in its spin for at least three factors, which means obviously it used to be going faster. This puts a time limit. For one thing, the textbooks are going to tell the kids the Earth is billions of years old. The Earth formed, according to them, 4.6 billion years ago. Now, at that time, the Earth would have been spinning an awful lot faster. If the Earth was spinning, say, let's just say it's spinning 20 times faster, the Earth is almost a perfect ball. What happens to a ball when you spin it real fast? Flattens out, becomes like a frisbee, right? So if the Earth was cooling down 4.6 billion years ago and spinning lots faster, it wouldn't be round. The crust would have hardened in an egg shape, frisbee. We wouldn't have a near perfect ball. The Earth is flattened right now. The poles are pulled in, I think it's 20 miles. It's about 20 miles wider at the equator than it is at the poles because of its spin. It's pretty heavy, and just the centrifugal force going around at 1,000 miles an hour, it's pulling it out a little bit. So the Earth is spinning. Okay, the Earth is spinning is a scientific fact. How fast it was going a billion years ago, I don't know, but it does put some kind of time limit. And evolutionists don't like time limits at all. They want to have billions and billions of years. Another factor here. The Sahara Desert is the largest desert in the world. The wind almost always blows the same way because of the Coriolis effect. It happens to be in an area where the wind blows the same direction most of the time. The hot air comes off the desert and kills the trees at the edge, and that area becomes desert. The process is called desertification. That'll be a good quiz question. The process by which deserts grow. What happens is, Once the area becomes desert, all the minerals leach out of the ground and nothing will grow there again. You take pure, hot, baked sand and plant some seeds in it, there's nothing there for them to grow on. And so the soil actually gets sterilized. Nothing will grow. Sahara Desert is 1,300 miles north to south. This textbook tells the kids, notice the picture here, past Sahara Desert was pretty small, wasn't it? The yellow part. Then the pink part is the present. Possible future extension. People living right on the edge of the Sahara Desert are making the problem worse because they want to build a house or have a fire to cook their food. There's only a few trees anyway, so they cut them down. And now there's no trees. You get a good rainstorm, what happens to your soil? Washes away. Now you can't plant your crops because your topsoil is gone. So they move on further south. Because of the desertification process and because of people and their poor farming practice, the Sahara Desert right now is growing 4 miles a year. At 4 miles in a year, at 100 years, that's a problem. What used to be good, beautiful farmland is now desert in a hurry. What are all these people going to do? Keep moving. Where? Onto somebody else's property. Going to create a problem, right? Regardless of the human suffering and tragedy going on over there, and it is a tragedy, because of this process, this desert is growing. But even if no people lived there, the desert would still grow because of the hot air killing the trees and grass at the edge, and the soil gets sterilized. They did quite a study on this and said the Sahara Desert is about 4,000 years old. Actually, now with satellites, they can go up and fly over with the satellites and look down and see where old rivers used to be. Riverbeds all over the Sahara. Used to be a lush tropical forest. Sahara Desert's about 4,000 years old. Now that brings up an interesting question. If the Earth is billions of years old, why don't we have a bigger desert someplace? Why do you think the largest desert in the world is less than 4,000 years old? You have a theory about that, Dan? Yeah, me too. You see, about 6,000 years ago, God made everything. 4,400 years ago, there was a flood. In this flood, everything drowned, of course, and it's pretty hard to have a desert under a flood. And so the biggest desert in the world should be less than 4,400 years old, if the Bible is correct. Oh, and it is. Well, what do you know? So here we have an interesting correlation that the Bible date is correct. Roughly 4,400 years ago, a worldwide flood. When they drill down into the ground, they hit oil. The oil's under pressure. Up to, I don't know, I've not heard of any exceeding this, but up to 20,000 pounds per square inch of pressure. That oil wants out of there. How many have ever seen the movies where they drill down and hit a gusher? The oil comes squirting up out of the ground, okay? Not all oil wells are that way, believe me, but some are. Incredible pressure. When we lived in Texas, we had a lot of guys that worked in our church that worked in the oil field. And being a science teacher, I was always curious about the oil, and how do they do this? And I would go out and visit the oil wells and, watch them drill this stuff. They drill down about 1,000 feet, a big 12-inch hole. That's quite a post hole digger, by the way, they've got for that. They dig down 1,000 feet. Then they put a special donut down there called a blowout preventer. And they run wires up to the top to a switch. Then they go and they drill through the middle of their blowout preventer. They drill a 4 or 6 inch hole the rest of the way down. If they hit a high pressure pocket, the switch automatically trips to close it off. Because in the early days, they would drill down for gas or oil. They hit one of these high pressure pockets, and it comes shooting up out of the ground so hard, it eats the side of the hole away, and the hole gets bigger and bigger and bigger from all this oil squirting up. Pretty soon, everything falls in the hole. People, buildings, tractors, everything. There was one in East Texas, I believe, where it ate up an entire acre, collapsed. Killed a bunch of people. Everything just swallowed up into the ground. It wasted a lot of oil, too. Blows all over the place. So now they prevent that with what's called a blowout preventer. Who cares, right? The fact is, oil wells often have incredible pressure down there. Now, the guys who deal with this have to have special tubing, special valves, special equipment. They're ready to handle incredible pressure. The scientists who studied the rocks on top of the oil say this rock can't handle the pressure for more than about 10,000 years. The pressure should have leaked off. What would eventually happen is the rock's going to crack. When I was in Texas, in the middle of oil patch in Longview, Texas, we had guys, I'd go soul winning, and they would say, oh, I do frack jobs for a living. So you do what? He said, yeah, we drill down, we pump the oil out of the ground. Now you got to figure way down there it's like a big sponge, only hard rock sponge, a sandstone sponge. You pump out the oil, it soaks into the hole, you pump out some more, and you got to wait till more oil soaks in. The oil's not in any hurry to get to the hole, just gravity fed, okay, or under pressure. But after a few years, you've pumped out an area about as far as you can get. Now your oil well quits pumping. Nothing down there to pump anymore. So they pull the pump out, pull the well out, pull the pipe out. They pour in a bunch of liquid nitrogen, and then quick pour a bunch of concrete in the hole to fill the hole in, maybe 100 feet of solid concrete. The concrete hardens, the nitrogen is hot, turns to gas, expands, and it creates so much pressure, it cracks the rock underground. And cracks go shooting out for hundreds of yards in all directions. It's an underground explosion is what it is. And they're fracturing the ground out, from here to PCA. Now the oil over there has got a crack to flow through, so it flows into your hole. You can start pumping it again. Of course, now you got the problem. You've got your concrete plug. You got to drill that out. So it's a real expensive process, but that you can study all that if you'd like, get into oil production. But the fact is, we do have pressure. It doesn't last long. So two obvious questions should come up. Why is there oil in the ground? Where did it come from? And why does it still have pressure? Nearly all scientists agree that oil comes from organisms, living organisms, that are squeezed and heated. Under pressure and heat, you can convert a ton of garbage to oil in a few minutes. There's a good article in Creation magazine, Creation Ex Nihilo. If you get the 1990 edition, I believe is where it is. Also, Impact article number 155 are some good ones to read if you want to study. And Eric, you should do this. Definitely read up on oil formation. Scientists can take a ton of garbage and squeeze it into oil in the laboratory in about 20 minutes. They did a test where they took some organic material. Now, the word organic means something that used to be alive. Plants, animals, okay, is organic. Oil is, almost everybody agrees, comes from organic material, plant or animal or human. Under pressure and heat will change to oil. Hitler, it is reported, some of the Jews that were killed, he took the bodies and had them baked to produce oil for his tanks. I don't know, I can't verify the story, but I've had several folks tell me, yes, it's true, that they didn't do that with all of them, but they did it with some to see if it would work. They'd found it was too expensive to do. Okay, the pressure and heat produces oil. So I don't know what the numbers are, but let's say you can make a barrel of oil for $1,000. You take a ton of garbage, squeeze it, heat it, turns to oil. One person said to me the other day, why don't they make oil that way, cut the price of gas? I said, well, you can drill and pump the oil out of the ground for about 20 bucks a barrel. If they start producing it for 1,000 bucks a barrel, your gas is going to cost, $1,000 a gallon. You better leave it alone, okay? It's still cheaper to drill it. The fact is it could be done. It just isn't practical to do that. So oil can form quickly. So the obvious question would be, how did the oil get way down there in the ground? 3, 4, 5, 6,000 feet down, 2 miles down. All over East Texas, they drill down 3,800 feet, I believe is the number, and they get into the seam where all the oil is. They can pretty well count on it. We drill down 3,800 feet, you're probably going to hit oil. In Kilgore, Texas, remember the oil museum? They had 28 oil wells on 1 acre, the size of our property. They called it the world's richest acre. They pumped it for years and finally pumped it dry. Today it's just a museum. Okay, there's no more oil, not enough oil down there to make it worth going after. But Sinclair Oil Company has the dinosaur as their logo because they say the dinosaurs turned to oil. And they're probably right. And they, these guys drill for oil all the time. Sinclair is still a very valid company, mostly out west. You don't see them much here, but in Arkansas there are Sinclair gas stations, and all over out west, Sinclair Oil Company. The article, How Fast Can Oil Form? Creation Next to High-Low, Volume 12, number 2, page 30, talks about that. I've got this sign in my office from Sinclair saying that dinosaurs have been mellowed for 80 million years. Now, slow down a minute. Yes, the dinosaurs probably turned to oil, but it wasn't 80 million years ago. I think that all happened at the time of the flood. Very simple. You got a world full of people, full of animals, full of plants. Now you get a flood that destroys everything. The flood lasts for a year. At the same time as the flood's going on, you got volcanoes blasting ash and lava up, and you got all kinds of bad things happening to the earth. You're going to get all these carcasses buried under thousands of feet of mud, sediment, debris, rocks, lava, ash. The pressure, how much does a cubic foot of water weigh?
8 pounds.
A gallon is 8 pounds. 62 pounds, 64, 62 pounds, okay, depending on what kind of water it is, salt water, etc. If you lay it on the ground and I put a box 1 cubic foot on top of your stomach and filled it full of water, 62 pounds. Let's stack up 10 of those boxes. 10 feet of water puts 620 pounds of pressure per square foot. Let's stack up 100 of them. 6,200 pounds of pressure per square foot, right?
Now, wouldn't it be different if you were surrounded by water?
If you're down in the water, yes, it's different. However, your eardrum is a little piece of skin stretched across an air pocket inside. That's why when you go down in deep water, the air pressure pushes on your eardrum and stretches it, pushing it in. And you have to go slowly so your air inside your head, in your eustachian tube, can equalize the pressure. That's why when you go up and down the mountains, you have to hold your nose and blow, to pop your ears, to equalize the pressure. Scuba diving, you have that, especially if you have sinus trouble, you have trouble scuba diving because, your ears will never equalize. Who cares, right? Rock weighs more than water, right? Let's say a cubic foot of rock weighs 100 pounds. It's probably a lot more than that, but let's just pick a number. 100 pounds per cubic foot. Let's stack it up 3,000 feet deep. How much pressure is it putting on 1 square foot 3,000 feet down? Is that 300,000 pounds per square foot? That's a lot of pressure. That's for 3,000 feet. Oil is anywhere from 3,000 to 10,000 feet down. So the pressure of the rock above is enormous, plenty, and since it's just pressure, pressure produces heat. So you got exactly what you need, pressure and heat, to convert whatever was buried to oil. If they can do it in the laboratory in 20 minutes, it certainly can change in 4,400 years from buried carcasses into oil. So that's where the oil came from. I believe the oil came from the people and animals that drowned in the flood. So I tell them, when you go to the gas station, you can say, "Bye, Grandpa, you should have listened to Noah. He told you it was going to rain." And that's probably what happened to the people that did not listen to the Lord. One more thought here. Young Earth, and we'll take a quit for the evening. In Denver, Colorado, I was preaching out there, and some guys came to the meeting. They said, "Now, Mr. Hovind, we know you teach the earth is only 6,000 years old. We would like to prove to you that you're wrong." I get this just about every week. You probably will too, right? These guys worked at the Denver National Ice Core Laboratory. Denver National Ice Core Laboratory. It is a section of the Federal Center in Denver, Colorado. What you're seeing here is a picture of a giant freezer. This freezer is enormous. The guys who brought me into this freezer, it's 36 below zero in there all the time. Taxpayers are paying the electric bill, so, set it where you're comfortable. The freezer is enormous. These were the guys that go to Greenland and drill holes through the ice. They also go to the South Pole and drill holes. The Russians are doing this too. They take these, it's called a coring machine. Here's a picture of one here. It's like a pipe. It drills down, maybe a 4-inch pipe. It drills down just the outside. So the center part is not disturbed. It's called a coring machine. I asked them, I said, "Now, when you're drilling a pipe down into the ground and you pick it up, doesn't the piece fall out?" They said, "Oh no," they showed me the thing, how they do it, the drilling machine. It's got little flaps in there down near the bottom. When they stop turning, as soon as they start to lift up, these flaps come in and catch. So they drill about a 6-foot section at a time. They drill down As soon as they start to lift it, it snags the bottom and breaks it off. So they pull up a 6-foot piece of ice about this big, slide it into a tube,